Okay, everyone, let's talk about probability and distribution. I plan to use 30 videos to talk about this topic. The first video is going to be about a very basic probability, and the second and the third video, I'm going to talk about various forms of distributions and how to calculate probabilities related to those distributions. So let's begin with probability, the very basic probability. So what do I mean by very basic probability? Is those questions such as there are several balls in the bag, and those balls have different colors: red, black, white, green, these colors, and you draw a ball from the bag. What's the probability that the ball is the color of the ball is red, or the probability of the color of the ball is white or black? Those are very simple probability questions. And these questions, you don't need to know the distribution, the distribution of the result you're gonna get. You don't have to draw a distribution. You just need to write some fractions, multiply them or add them together, then you get the result. That's very basic probability. So I'm going to talk about some of the concepts and definitions related to probability, and some of the very basic rules when calculating. So the first thing we need to know about probability is that oops, sorry, let me erase this. Okay, the first thing we need to know about probability is that when do you need to know about probability? Just like the example I made before, you need an event so that you need an event to calculate the probability of that event, right? You need to do some experiment. You need to do some experiment. You need to get some sample point so that you can calculate probability. And we have learned this concept in class. What is experiment? What is sample point? What is sample space? So, based on my experience, a general rule of thumb for calculating probability is that you write a fraction. You put a sample space. Sample space is all the results you can get as the denominator, and you put the sample point you want, the sample points that you want to calculate the probability. You put that as the denominator, and that fraction is the probability you want. So that's a very, very general rule. However, a lot of times you don't need to remember this rule to calculate probability. But if you met some obstacles, you have difficulties about how to calculate some certain probabilities, this rule is going to be helpful. It can give you some insights and some ideas. So just remember it. It's gonna be useful. And then the third thing is set. Professor didn't mention set, this specific name in class. Instead, professor talked about unions and intersections. So about unions and intersections, an easier way to understand this concept is through set. And you can see already here Venn diagram. You can draw a set by Venn diagram so that you can understand what is union and intersection. So what is Venn diagram? You must have seen this before, you just don't know its name. Maybe you just don't know its name. So Venn diagram is you draw a rectangle here, and this represent the sample space. Remember, the sample space is all the result we can get from a certain experiment, right? And we have two sets here, set A and set B. So for set A and set B, they could be one sample point or several sample points combined together. And union is, I will change the color. Union is you combine set A and set B. So we write union in this way, and union is just this area. This is the combined area that set A and B took in the sample space we give it. And as for intersection, we write it this way. And intersection is, let me change another color. Oh yeah, let me erase this. And intersection is the space here, is the area here, is the overlapped areas between set A and B. So Venn diagram it's a very useful tool to understand the concepts of union and intersection. You can draw it and it shows you directly what is union, what is set. What is union, what is intersection, right? So keep in mind, it's gonna be helpful. Then about two-way table. In class, we talk about a two-way table. A two-way table is just a way to present your sample space by classifying those sample points into two different groups of characteristics, right? So for example, we talk about the poker cards in class. A two-way table looks just like this, right? And if you see the definition I gave here, so here is just one group of characteristics, and here is just another group of characteristics. So in terms of poker card, it can be here for example, we have diamonds, and here we have hearts. And here we have another kind of characteristic, right? It can't be diamond, heart, or spade, or club. It has to be something else. So it could be ace or not ace, right? So this is just a two-way table. It classifying the whole sample space into two groups of characteristics. And then we talk about complementary event. Let me erase this. About complementary event, one thing you need to know is that if A and B are complementary event, then the probability of A and B they add together equals 1. So if you see this by drawing a Venn diagram, it could be like this. Again, this is the sample space. A and this is event B. They combine together, the probability is 1. It's the sample space. And down here, you can see mutually exclusive event. They're easy to understand. It's just these two events, they don't happen together. And the complementary event is actually a good example of mutually exclusive event. A and B, they can't happen together, right? They don't have overlapping. But for event A and B here, They are not mutually exclusive because they have overlapping. And if you draw this into a Venn diagram, it could be like this. Event A and B, they won't happen together. They have no overlapping. And this formula, the formula here, it's very easy to understand, and it's not too useful. Then here we have conditional probability. Conditional probability, you need to remember this formula. Oops, I cannot mark them. I will just draw it by myself here. You need to remember this formula. This looks a little bit scary, right? When I first look at it, I'm thinking, what the hell is this? But if you think this way, it is called conditional probability. It's not called probability, but you add conditional before probability. It means that you add some constraint on the probability you are going to calculate. So it is essentially the probability of the event on the condition that another event has happened. So the example here is that we want to calculate the probability of event A on condition that B has happened. Right? B has happened. So it's essentially change the sample space. If you think like this, right? Remember the general rule of thumb. I wrote it here. You put the sample space as denominator, right? Oh, sorry. The general rule of thumb here, you put the sample space as denominator. So if you look at this Venn diagram, if you look at here, this Venn diagram, the sample space you put at denominator is the big rectangular I'm writing, right? But if you move to conditional probability, the probability of A on condition that B has happened, you should change the sample space. Change the sample space to what? To B. You treat B as the new sample space. If you treat B as the new sample space, this is B, this is the new sample space. So these areas, they become useless because they are outside B. They are outside your new sample space now. So if you treat B as your new sample space, A is just this small area, right? The overlapping area. So this is the probability of A on condition that B has happened. Remember, this rule is very important and it's very helpful. Why I spent so much time talking about this rule? Because a lot of questions you are going to face are just conditional probability. But it is not presented in a way that you can easily understand it is conditional probability. So just keep in mind how to change the sample space and how to calculate, how to use this formula. Then we have independent event. Independent event is just the event, they don't have influence on each other. And the formula here is pretty simple. Now we move to the first rule we're gonna learn is additive rules. Is the rule how you calculate the union of two events, the probability of the union of two events, right? if you take a look at the Venn diagram we draw again, this is event A and B. You want to calculate the union of A and B is the outer circle here. Now this formula becomes very straightforward, right? In order to calculate the area of this, you need to use the area of A, PA plus PB, and you minus the overlapping area, which is the intersection of A and B. So if two events are mutually exclusive, like here, two events are mutually exclusive, then their union is just PA plus PB, because there's no overlapping. You don't need to minus anything. Then we move to permutation. Permutation, we often write in this way: P and K. I don't know if I write it correctly. Is it P and K or PKN? But anyway, it's just mean you draw casings from N. It's like you have N balls. A simple example, you have 10 balls of different colors. You want to draw 5 balls. Then how many ways of drawing you can do? So this is how to calculate it, by using factorial. One thing to remember is that the factorial of 0 equals to 1. Then we have combination. You notice any differences here? Combination and permutation. So get back to our example. We have 10 balls, we want to draw 5 balls, right? So the differences for permutation and combination, you can use permutation and combination, either permutation or combination for this question. But the differences is here. If you use permutation, if you use permutation, it means that these 5 balls you draw, they have a certain order. They have a certain order within themselves, within the 5 balls. And if you use combination, you see this factor of k here? It means that the internal order of this 5 ball doesn't matter at all. Right? If you use permutation, the way you calculate is that you have 10 balls, you draw 5. It's 10 times 9 times 8 times 7 times 6. But if you don't care about the internal order of this 5 ball, then you need to divide the internal order of this 5 ball, because you don't care about the order. So you need to rule out of the order. So how to calculate the order of this 5 ball is it's just 5 plus 4 plus 3. Sorry, not plus. Times 3 times 2 times 1. So this is the differences between permutation and combination. There's no order here, but there's order here. So when doing questions like drawing balls or drawing poker cards, you need to pay attention. Do they care about order? If they care about order, permutation. If they don't, combination. Right? Then we move to the multiplicative groups. So this rule, you look at the formula here. This rule is just mean that it's a way to calculate the intersection of event A and B. And if you look at this part of the formula, it's essentially a conditional probability. So you can remember it as, like I said, when we are calculating the conditional probability, we change the sample space, right? For example, here, obviously the new sample space is A. And we times PA again, it means we change the sample space back to the old sample space. So in conditional probability here, this is the change of sample space, change to a new sample space. And here is essentially change the sample space back. That's this rule about. And the last thing I want to talk about today is Bayes' rules. Bayes' rules, I found this rule pretty useless, really pretty useless. I'm not saying that Bayes' rule is useless in real practice. I mean, it is useless for exams and for homeworks. It is useless. You may, at first sight of this, you may think, what the heck is this? This looks so complicated. But I can tell you that it's very easy to use, right? For Bayes' rules, this is the formula. And how to use it? You just need to find a list of events, like this. And when they are added together, they equal 1. They equal the sample space. And then you got another event, A here. So you can calculate some sort of conditional probability of a single event on condition that event A happened. So if you face a question saying that we have this event and the probability of them add together equals 1, and we have another event, and now we want to know the probability of this would happening in this. That question means you need to apply Bayes' rule. And you need to make sure you got the B1, B2, and BK, and you got the event A correctly. Then just plug them into the formula. The following formula is very straightforward, right? These are all the things we talked about before. They're very straightforward, just calculate. Then you get the result. If you met a question about Bayes' rule in exams, it should be pretty easy. So that's basically everything I want to talk about basic probability. In the end, I have last 2 points that I want to mention. The first one is that when you are calculating these probability questions, what you really need to do is what you really need to do is find the you need to make sure what is the experiment you are going to carry out. What is the experiment you are doing? And second thing is that how many situations are going to happen in that experiment. The third thing is that what is the relationship between those situations, between those isolated situations you just found. And there are two possible relationships. The first relationship is that you add them together. For example, you have experiment, and this experiment you have a target here, and you find several isolated situations. If any single one of them can reach the target, it basically means that you need to add the probability of this situation together. However, for another kind of experiment, if you find several isolated situations, but you need to carry out all these situations in order so that you can reach the target, then the relationship among these situations is multiplied. You need to multiply them together. So these are the two types of situations of relationships you are going to have with the different situation you want to calculate. Sometimes there could be multiple relationships, right? There can be like this. You need to multiply here and then add here. Just figure out the relationship. Then you can get the result. That's just 3 steps. First, figure out what kind of experiment you're doing. Then, isolated different situations. Finally, figure out their relationships and calculate the probability. That's the first thing. And the second thing, and the last thing I want to say is that probability and distribution, they are very, very important for statistics, especially distribution, and especially a normal distribution. Half of this class, especially after midterm, we are going to focus on the normal distribution. But that doesn't mean they are hard. They're actually pretty easy. So until this point, I also included Bayes' rule here, but I don't think I actually include it. But until this point here, you can see I also have the distribution part below. But until this point, these knowledge are all about very basic probabilities. They are very basic probability. They are the simple probability questions. But at the same time, these types of questions, they are, for me, based on my experience, I don't know what you think, but they are the most difficult probability. Because just like I said, you have to isolate every single situation and figure out their relationship. It sounds easy, but it's not. Think about the football team question we just did. How difficult is that? There are so many situations in that question, right? So I think this part, they are difficult. Although I gave you so many formulas here, they This seems pretty useful. But when you do your questions, your homework assignment, you're going to find that, wow, they're not useful at all, right? We don't need to know kind of rules and this to do questions. We just don't need them. So they're kind of difficult. You have to come up with all those solutions yourself. But the following part of distribution and probability, I guarantee you they are easy. Why? Why they are easy? Because they have specific sets of formulas for you to use. And from a mathematically perspective, you don't understand how to derive those formulas. You just don't know how to solve those formulas. But you know how to use those formulas. You know if you input this and this, then this values into those formulas, you will get the desired result. So the following part of probability and distribution, they are easy because they are specific formulas for you to use. You just need to input the numbers, then you get a result. But the difficult part is you need to know what is the correct number you need to input. If you input the wrong number, the formula will give you the wrong result. The wrong result, right? So the formula is just like a black box. You treat the formula like a black box. You give its input, you get output. That's the result you want. You don't care about how the formula works. You just don't care about it. You care about the input and output. That's all. So the following part of probability and distribution are going to be easy. But sometimes they may be not so easy to understand. But once you know how to do the input and output, then you're good. So that's all I want to talk about in the first video of probability and distribution. We will continue our discussion with distribution in the second video. Okay, bye bye for now.